Greetings, math fans. All right, so this is day 4 of chapter 1. And if you recall from day 3, we introduced parametrics, okay? And what we did there is we actually converted a parametric to rectangular, all right? And I showed you you had to put your initial and terminal point, you had to graph it. So what we're going to do today actually is we're going to go the other way around here, and we're going to convert from rectangular to parametric instead, okay, instead of going into rectangular. So I wrote down here just a quick wording here. Okay, it says another word for converting from rectangular to parametric is parameterize. That's how you say the word, parameterize. It's kind of a fancy word. Again, I think that will get you some mashed potatoes at home if you use that word during dinner. I would recommend that. Okay, so anyway, the word is parameterize, or I might say find the parametrization. That's even more complicated. Find the parametrization, okay? Sometimes it can be challenging to find the restrictions, and that's what we're going to talk about today. So we're going to actually show how to convert, which is really easy how to convert, but then finding the restrictions is a little bit more of a challenge. So that's what we're going to work on today, okay? So let's do our first example here. It says graph the right half. So this again is a restriction here. Graph the right half of the parabola y equals x squared minus 4x. All right. So the first thing I need to do is, if I'm graphing the right half, I kind of need to know in a parabola the right half is to the right of the vertex. So I really need to know what the vertex is. So let's do that first. The vertex is going to be opposite of b over 2a, which you need to know that, right? And of course, a is 1, b is negative 4. I don't really need c here. So opposite of b, so it's 4 over 2 times 1. So it's 4 over 2, which is 2. And then you take that 2 and you plug it back into the equation. So 2 squared, which is 4, minus 4 times 2 minus 8, which gives me negative 4. So that is my vertex. Very, very important. All right. Then I'm going to make a quick t-chart here. And by the way, I am just graphing this for now. I'll actually come up with the parameterize it in a second here. So I'm going to plot that, and I really just need, since I'm doing the right hand of the parabola, I just need points to the right of it. So 2, 3, and 4. We put the 2 there as well. 2, negative 4. I plug a 3 in, I get negative 3, and I plug these 4 in, I get a 0. Okay, so let's go ahead and plot that. 2, negative 4 is here. 3, negative 3 is here. And 4, comma 0 is here. So you guys should know it's a parabola. Okay, graph it nicely. Don't give me, don't draw a straight line, right? So here's the graph. All right. Looks pretty good. Nice little right-hand side of your parabola. Okay, so 1b says completely parameterize the graph. Now, this is actually really easy to do. So what we're going to do is, well, here, let me just cursor down here. Okay, this is your equation, right? That's your equation. Y is equal to x squared minus 4x. So watch, this is all I'm going to do here. I'm just going to say, hey, I'm going to make x equal to t. Because remember, it's got to be in terms of t. So x equals t. And y is equal to, well, if x is t, then I can just substitute the t in for that x there. So I get t squared minus 4t. What? That's it. Okay, that is parameterizing it. But we need one more thing. Okay, we need a restriction. So it's actually pretty easy, because if x is t, well, what is x in this this graph here? Now, look closely, because it's the right half. So that's another reason, math fans, why I found the vertex. Because do you guys agree if the vertex is 2, negative 4, and if I want to find the right half, it starts at 2 and then goes to 3, 4, 5, and goes to infinity? So really, you're going to say t, because we're making restrictions on t now. So t is going to be greater than or equal to 2. Okay, because of this guy right here. Now you might say, well, Mr. Curvis, shouldn't it be just greater than? Yeah, I guess technically it really should just be greater than, because it's the right half. So it's fine. If you want, I can just get rid of that. Okay, so technically a t is greater than 2. Okay, that is the right half of the parabola. Pretty easy. Okay, but remember that restrictions got to be in terms of t. Okay, so write that down someplace. Restrictions must be in terms of t. Very important, very important. Okay? All right, let's move on to the next one. It says graph the part of the function y equals the square root of x plus 6 in quadrant 2. All right, so first of all, I need to kind of graph this just to see what it looks like. So let's pick some values here. I'm going to make a t-chart. And I'm going to pick some x and y values. Okay. Now, again, be smart about it. You want to pick numbers where I take the square root. I don't get like the square root of 3 or square root of 7 because I don't really know how to graph that. Is it 2 points, something, 3 points? I don't know. Okay. So I'm going to pick values that are smart. I'm going to pick -6 because that's going to give you square root of 0. And then I want 1. I want the square root of 1. I want the square root of 4, the square root of 9, the square root of 16, right? To give me good quality values here. So if I put -6, I get 0. Square root of 0, 0. If I picked -5, I put -5 plus 6 is 1. Square root of 1 is 1. If I pick -2, -2 plus 6 is 4. Square root of 4 is 2. If I pick 3, 3 plus 6 is 9, square root of 9 is 3, and we pick one more, which is 10. 10 plus 6 is 16, square root of 16 is 4. Okay, so those give us nice values here. Okay, so now what I'm going to do is I'm going to plot some points here. And I got -6, 0 is right here. -5, 1. -2, 2. 3, 3. And 10, 4. So if you notice, it looks like you should graph this whole thing and it should go to the right. But here's my restriction, guys. I said quadrant 2. So really, I'm just graphing this part right here. And it's going to end somewhere over there. Okay, that's it. Like it's kind of supposed to be a little curvy, but that's okay. Kind of chose a pretty thick line here. Okay, but that's my graph, guys. Okay. So let's look at number 2b. I need to completely parameterize it. So again, it's going to be really easy, right? You're going to say x equals t and y is equal to the square root of, and of course in terms of t, well, t is x, so I can just say t plus 6. Super easy to parameterize it. Now let's look at the restrictions. Okay, do you guys agree? Again, it's got to be in quadrant 2. Do you guys agree the x value is going to be -6? If you again, I drew the graph in the correct spot. So the x is between -6 and what? 0, right? Because I mean, even though you don't have a value for 0, it doesn't matter. It's got to be between -6. So t is between -6 and 0. Now, technically, as I said before, I don't really need this bottom part because really in the second quadrant. So this is my final answer here, math fans. Okay, so x equals t, y is equal to the square root of t plus 6, and t is between -6 and 0. Because if it went less than -6, you'd go in quadrant 3. And if it would be greater than 0, it would be in quadrant 1. So that's it. Okay, it's not bad. Okay, let's keep going here. So we're not doing any more graphing here. We're just going to do find the parameterization, and of course, with that comes restrictions. Okay, so number 3 is find the parameterization for the part of the graph, and you have a nice little quadratic that lies in quadrant 3. So the parameterization is actually really easy, right? I mean, I could do that. It just x equals t, y equals negative parentheses, t plus 3 squared plus 1. I mean, that's like really, really easy. It's actually the restrictions that cause a little bit of difficulty. So if I make a quick sketch here, the first thing I need actually is the vertex, right? So the vertex is -3, 1. So let me go ahead and plot that. So negative 3 comma 1 is right here. And I know that graph is going to go down because it is negative in front of the that x squared term. But remember, in order for it to be in quadrant 3, it's got to be somewhere, right, somewhere in this area here. Okay, so I need to figure out, it certainly can't be by the vertex because that vertex is in quadrant 2. And I need to figure out, does the graph look like this? You know, curve down like that? Or does it look like this? Right? Because these are two different values here where it, like, the first one I drew, the wider one, basically there's nothing to the right of the vertex where it crosses into the quadrant 3. Do you guys agree with that? So I'm actually just going to erase this one. But I mean, what we need to do is we need to figure out where it's crossing. Okay, somehow it's crossing somewhere down by the x on the x-axis, but we need to figure out where. So how do we do that? Well, we need to figure out when x equals, or when y equals 0. Do you guys agree with that? So what I'm going to do is I'm going to set negative x plus 3 squared plus 1. I'm going to set that equal to 0 because I want to know where it's crossing the y-axis or the x-axis, right? Where I'm trying to say where y is equal to 0, it's going to be crossing the x-axis. So you just set that equal to 0. It's real easy. So that's going to basically tell me where below the x-axis it is touching. So if I solve that, I subtract 1 and then divide by negative 1. So I wind up getting x plus 3 squared equals 1. Take the square root. I get x plus 3 equals plus or minus 1 and subtract 3. So x equals negative 3 plus or minus 1. So I get two values. I get negative 3 minus 1 is negative 4 and negative 3 plus 1 is negative 2. So that's where it's crossing. So let me erase a little bit here. Let me just get rid of this. And I can kind of draw a quick sketch of where it's going to happen. So at negative 4, it's going to cross. And at negative 2, it's going to cross. So this is kind of what the graph is going to look like here. Okay. So what's going to happen also, as I draw this on the right here, eventually it's going to cross. You agree with that? Eventually it will. I mean, if I put, we can figure out that value, but I kind of figured out ahead of time here, and basically it will, it's going to cross at, I believe, negative 8. So, right, if I put a negative 8 into the equation for y, you're going to get a 0 for x. Okay? So, this is important in that just x equals 0 here. And this is important because x equals negative 2. Okay, for restriction. And this is important because x equals negative 4 here. And then, of course, this goes on to infinity. All right, so if I put this all together, the first part's super easy. X equals t. Y is equal to negative parentheses t plus 3 squared plus 1. Okay, and the restrictions are, look what the x values are. Well, it's from negative 4 to negative infinity, so I will say negative infinity to, and this is t is this value now, negative infinity to negative 4. I'm going to put a parentheses there because, again, it's got to be in quadrant 3, which means it doesn't include that value. Okay, union negative 2 to 0. That's it. That's my answer. Okay, so think logically. In order for it to be in the third quadrant, that's what x has to be. It has to be between negative infinity and negative 4. And then all of a sudden from negative 4 to negative 2, it goes above it. It's in the second quadrant. And then from negative 2 to 0, it's in the third quadrant. And past 0, it's in the fourth quadrant. Okay? So it's a little tricky. I mean, but just again, you're smart kids. Just think about what makes it in what quadrant. Okay, what values of x, what values, it's really what values of x make it, or values of y make it in the whatever quadrant you're looking for. Okay, so that would be your answer. Okay, so let's do the next one here. It says, find the parameterization for the line segment with endpoints of -3, 1, and -6, 4. So the thing I have to do here, math fans, is I need a rectangular equation first in order to convert it into a parametric. So we need a rectangular equation first. And if I'm giving you 2 points, how do you come up with a rectangular equation? It's pretty easy. You just need a point and a slope, right? So we're going to say m is equal to, just going to use the yachts, right? Changing y over changing x. So we're going to say 4 minus 1 over -6 minus -3, which gives me 3 over -3 or -1. So that's my slope. And again, if I want to use point slope form, we're going to say, we'll use the first point. So y minus 1 equals -1 x plus 3. Okay, I'm actually going to now change it into slope-intercept form just because I really want to solve for y so that I can do a parametric. Okay, so I'm going to get y minus 1 equals -x minus 3 and add 1. So I get y is equal to -x plus 2 or minus 2. Okay. And that's it. So that's pretty sweet. That's my rectangular equation. And so it's actually pretty easy now because now I just, of course, say x equals t and y is equal to -t minus 2. Sweet, sweet. Okay. And now I need a restriction. I need to restrict, since we're talking about x first, I need to restrict t. Well, guys, this is really easy because I'm giving you the values of x, and if x is t, then you're just going to say t is between -6 and -3. Make sure you put it in the correct order, right? Don't say -3, -6. And so that's it. That's your answer. That is it, that parameterization for that line segment with those endpoints. Okay, not bad. Okay, so last one here. Number 5, find a parameterization for the ray. Now that's interesting. Let's kind of highlight that because it's important as opposed to a line segment. With an initial point of 4, -1, and passes through -1, 4. All right, so just to kind of put here, this is not a line segment, which is what we did right before. But we're going to do the same work because we really need a point and a slope. We need an equation. So we're going to do the same as number 4. So we're going to do slope. So y, or m is equal to -4 minus -1 over -1 minus 4. So -4 plus 1 is -3, and that's -5. So my slope is +3/5. Okay, cool. And so then we're going to just use the first point here. Y plus 1 is equal to 3/5 times x minus 4. So now the other one I converted into point slope form or slope intercept form. Okay, it's the only reason I asked you guys to do that is because if we do a problem in the calculator, you can't type in y plus 1. It's always y equals. So I can write it as y is equal to 3/5 x minus 12/5 and then minus 1. So I get y is equal to 3/5 x minus 5/5, so it's minus 17/5. Okay, so that is the rectangular equation. Okay, so then I can say my parametric is x equals t y is equal to 3/5 t. It's a t minus 17/5. Sweet. So now think about a restriction. Before it was between these two x values, but remember guys, it's a significant, it's array. So it's an initial point of 4 and it passes through -1. So do you guys agree it goes 4 and then 3, then 2, then 1, then 0, then -1, -2. It's going through that. It's not stopping there, it's going through that. So really, I'm going to write t is less than or equal to 4 because it's going lower. It's going toward -1. Like if that -1 was a 10, then you would say t is greater than or equal to 4 because it's getting bigger and bigger and bigger. Okay, but it's getting, in this case, it's getting smaller. And so that's it, math fans. That is parameterizing it as array as opposed to a line segment. Okay, so that's it. Not too long of a video, but you know, hopefully you guys are good to go with this. Parameterizing it, it's really pretty easy to come up with the equation. It's just a little more challenging to come up with the restrictions for t, but it's really not too bad as long as you understand what the graph looks like. Okay? All right, math fans, that's it. Have an outstanding day. Adios. Goodbye.